Hey guys, so today we are back with a different activity. Alright, so yesterday we looked at how I can react acids with metal carbonates, and we know that the result is definitely going to be carbon dioxide gas along with salt and water of some form. Alright, so today we are going to look at another reaction of a salt family that is close to carbonate but not the same. Okay, this is called as bicarbonate or hydrogen carbonate. Okay, so if you've seen formulae that have HCO3 together, HCO3 like NaHCO3 for example, so that is called bicarbonate or hydrogen carbonate. So this is another type of salt that can react with acids. Today we are going to look at this, how does an acid react with a bicarbonate salt. Now again, like usual, we can use any bicarbonate salt, doesn't have to be just one type. I'll be using sodium bicarbonate because it's easily available. If you know what is baking soda, right, that the formula for baking soda is the same. Okay, NaHCO3. Baking soda is nothing but sodium bicarbonate. And that's what we will use for today. And since it is an experiment, again I'll ask you take your notes down in the experiment format itself. All right, okay, we've already started with what is the aim of today's class, and that is to observe the reaction between a bicarbonate salt and an acid. Like I told you, the bicarbonate I use is going to be baking soda. The acid we use is the same, HCl, like we've been using for the whole chapter, right? Now that is my first two parts of my equipment or material, my reactants. Along with that, I'll use the same setup that I did yesterday, right? I will use a conical flask or a round bottom flask, whatever you call this. I'll be using this flask for doing the reaction, and I have again a small container of lime water with me. Okay, now I think when I say lime water, you should figure out that we'll be testing for which gas, and that is carbon dioxide gas. We'll see if we are able to do the Milky test properly today. We'll also do the test with the matchbox where the match gets put off. If that is it, then we'll know that it is definitely carbon dioxide gas. Okay, so I'll start with the procedure. I will again use my containers and I will add my reactants together. Okay, so I'll first take the salt, that is sodium bicarbonate. Since it's an experiment, we won't call it baking soda. Okay, we'll just call it sodium bicarbonate. All right, so now I have there. We'll add a good amount of it, right, just to make sure the reaction is brisk and copious and we have a lot of gas evolved to test. It will take a bit, but that is okay. Need to be careful not to spill. Now this is not a harmful chemical. We use it in cooking also, and the reason we use it in cooking is because it creates that fluffiness, right? If you remember, in cakes we use sodium bicarbonate or baking soda. Because of the carbon dioxide that it makes, it kind of fluffs up cakes. That's what makes cakes fluffy. Anyway, so that's what we'll figure out today, how is the carbon dioxide coming. Okay, so here goes the acid right into the container, and observe the reaction. Again, just like yesterday, there is some bubbling, fizzing, something that is happening, right? All of that bubbling is nothing but the reaction for carbon dioxide gas being produced, right? Now I will try to do this test again. This is not the right equipment for it, but we will try nonetheless. To see if it is even a slight chance of it happening. It tests two methods at once, right? Just keep noticing the color of the liquid in this small beaker. You'll see it starts going like a little opaque. That's what we should be able to see here. But I'm not able to see because my hand is in the way. But when it starts to go opaque, it's kind of for sure that this is carbon dioxide gas that is being produced. Now the reaction is brisk, it happens really quickly, so it's a little hard to tell like when the reaction is gonna finish so quick. You need to make sure it doesn't finish quickly. And I've been dripping this over here, but if you see here, you see this wispy white kind of something is formed, right? Yes, yesterday we weren't able to do it, but here it is. Now it was pretty much a clear liquid, but now it's a little smoky over here on the top there, if you see, right? Yes, we have successfully done the test that we wanted, and that is for carbon dioxide gas. I'm excited, I'm happy I was able to do this. So the best way to do it is with a delivery tube. So in your reader you'll have a different setup written. Preferably use that setup, although I'm not done it here, but the result is the same, right? Whatever gas is produced passes through a tube and goes into lime water, and it again becomes milky just like it has happened over here. I'm just trying to see if there's any more gas that is going to make it milky, or any more carbon dioxide, just so it's a little more clear for us to see. It's quite interesting, exciting for me. I don't see much difference, but yeah, now you'll see it has gone a little milky, right? Awesome. I'm glad this was able to happen today. And the final test, it might not work because there's like only a slight amount of CO2 left inside, but I'll still try to do the flame test. Goes off. Now the flame test is something that we try. Like I said, it's not indicative, meaning it's not for sure that it's carbon dioxide always. So that is why this is a very definitive test, okay? This is definitely true. So in your experiment, we will not write the flame test, okay? When you're taking notes, make sure you don't write about the flame test, write only about the lime water going milky, alright? In a different video, I remember we did one reaction where calcium oxide reacted with water. It was an example of an exothermic reaction. This is how we make lime water, by the way. We add calcium oxide to water and that makes lime water. As simple as that. Okay, so that's it for today. To recap everything that we did, an acid on reacting with a bicarbonate salt is also going to create carbon dioxide along with a salt, a different type of a salt, along with water, right? Since it is sodium bicarbonate here and hydrochloric acid, this is going to be sodium chloride salt or sodium chlorate salt, okay? So now I can definitely tell that sodium chloride plus water plus carbon dioxide are the products of this reaction. Okay, so that should look NaHCO3 plus HCl gives rise to NaCl plus H2O plus CO2. To balance it off, I think you need to do double NaCl, but yeah, that's secondary here. Okay. So that's the end of today's class. I'll see you in the next one. Thank you.